Interference. So going back to properties of a wave. Properties of a wave include that they can transport energy and information from one point to another. They need a medium to do this. However, the medium itself does not get transported. Only the energy and the information carried by the wave will get transported. Some waves, as we've talked about, light, for example, electromagnetic waves, do not need a medium to travel through. A disturbance or change in some physical quantity is passed from point to point as the wave propagates. For a light or radio wave, disturbance is a change in the electric and magnetic field. For sound, the disturbance is generally pressure and density. Please note that the medium will change its form a little bit, but then it will go back to the undisturbed state after the wave has passed. So type of waves include longitudinal. They are waves in which the medium moves back and forth in the same direction as the motion of the wave, like this, where one molecule will hit the next and the next and the next and the next, and the wave information will propagate and the medium comes back to its original state. Or it could be transverse. Transverse are those in which the medium is perpendicular to the motion of the wave. The medium moves up and down while the wave is transported forward. Here's another good example, animation of a transverse wave, what it looks like. Right? The medium comes back to its original state and waits for the next wave to come through. A progressive wave is set up by moving a wave. If you have a string attached to a wall and you move that string up and down, a wave called progressive wave is set up. This wave has a crest and a trough and the velocity going forward. Lambda is going to be its wavelength. Now, points on the wave that are in phase with each other are called in phase. Points of the waves that do not match up are called out of phase with each other. Interference. So when different waves collide, for example, sound from different sources, they interfere with each other. This is called wave interference. Waves that are exactly in phase add together to produce a stronger wave at the end, and this phenomenon is called superposition. Waves that are exactly out of phase are called destructive waves, and they give you zero output. This is how many noise cancellation devices work. Intermediate waves have varying phase relationships, and they produce differing sound effects. So some places the superposition will be larger, in other places it will not be large. Constructive interference example and destructive interference example. Again, how interference works. So if you have a green wave and a blue wave, and black represents the superposition of these two waves, you can see when they are exactly in phase with each other, it's constructive. When they are exactly out of phase with one another, it is destructive interference. Constructive and destructive.